Hi everybody, today we'll be looking at the fundamental theorem of calculus, which says if there exists a function, capital F of x, which is the integral of lowercase f of x, where f of x is a continuous function, on AB, then the definite integral is given by, and so we've got this S symbol, so it's from a to b of f of x dx. So we're trying to find this definite integral, and we're going to use the integral function, capital F, from a to b, and then we just go f of b, take f of a. So we've already seen this idea that to find a definite integral, we first of all need to find the integral function. And then the definite integral will be equal to the difference in the endpoints. But make sure that when you find the difference in the endpoints, that you do right point, take the left point. So it's important that, because that's the only way it's going to work. Now you may have a question, you may say, well, you may wonder, well, where has this plus c gone? Where's this plus c? We're only using f of x. So let's see where it's gone. Well, if I had this idea, so if my integral was f of x plus c, and I wanted to find that at a and b, then it would be f of b plus c take f of a plus c. And then that would give me f of b plus c take f of a take c. So those c's would cancel and I'd just get left with f of b take f of a. So what this leads us to is, for definite integrals, and it's only for definite integrals, not for indefinite integrals, the plus c is unnecessary. Now that you won't lose a mark if you include it, but it'll cancel out. So if you include it and don't cancel it out, then you will lose a mark, but it's easier just to not put it in the first place. So our process is always to find the integral function, and then we find the difference in the endpoints doing the right take the left. So here we've got to prove that one of our rules of definite integrals. So if I have the integral from a to b of f of x dot dx, and we're going to add to that the integral from b to c of f of x dx. Now we can't say that that's equal to the integral from a to c because we haven't done that yet. So we just got to go left hand side equals, and out here I'm going to say that f of x is equal to the integral of f of x dot dx. Now I should probably have my plus c because here we're dealing with an indefinite integral. Okay, now using that idea, I'm going to get f of b take f of a plus f of c take f of b. And if we go through and do that, I've got f of b here and take f of b there, so those f of b's will cancel. I'll get minus f of a plus f of c, which is f of c take f of a. But if we consider that closely, then we can just say that that's the integral from a to c of f of x dx, which is equal to the right hand side. So we've used the fundamental theorem of calculus in its forwards direction here to write it in terms of capital F of x, and backwards here to go from capital F of x to lowercase. Okay, we've got to prove this one, the integral from a to a of f of x dot dx equals 0. So here, if we go from a to a of f of x dx, maybe we can't say that's equal to 0 yet, but I'm going to say that f of x plus c is equal to the indefinite integral of f of x dx. So then I can say this is f of a take f of a using the fundamental theorem of calculus. Well, that's the same thing, so that's just 0. Okay, so now I've got a question from you. Can you prove this rule, that the integral from a to b of f of x dx is equal to the negative of the integral from b to a of f of x dx. Now, I want you to have a go at proving that, and then indicate on the quiz if you are able to prove it. So have a go at that, pause the video, have a go at that, and if you're able to prove it, click yes. If not, then just mention no, and I'll go through it in class. Okay, so we're now going to focus on some different examples. So the integral from 1 to 3 of x to the cube. Now remember, the process is always the same. So number one, we find the integral. Number two is right hand endpoint, subtract left hand endpoint. Okay, alright, so in this case, if I've got the integral from 1 to 3 of x cubed dx, well, what's my integral? Well, it's x cubed on 4. Add 1 to the power, divide by the new power. And we're going from 1 to 3. So we write these bounds out here just to remind ourselves what our endpoints are. So it's going to be then 3 to the 4 on 4, take 1 to the 4 on 4, and once we've done that, we can put it straight into our calculator, giving us 20. Now we don't put unit squared because it's not an integral, or rather it's not an area. Okay, with this one, it's going to be the integral from 4 to 9 of x plus 2x to the minus a half, so we'll just put it in power form first. So if I find the integral, x is just going to go to x squared on 2, plus now it's going to be plus 1 to the power, so we're going to get x to the power of a half, divide by the new power. 2 is also going to be out the front, so we're going to be dividing by a half, and we're going from 4 to 9. Okay, if I divide by a half, I'm multiplying by 2, so I'll get x squared on 2 plus 4 root x from 4 to 9. Now, when we actually calculate the endpoints, it's really important to put brackets, or else you can get yourselves into all sorts of trouble. So this will be 9 squared over 2 plus 4 times by the square root of 9. Close that bracket, put a subtract, open a new bracket for the other endpoint. So 4 squared on 2, take 4 times the square root of 4, close off that bracket. So because I partition things into nice brackets, it's going to help me get it right. So 81 on 2, 4 by 3 is 12, then it's going to be take. So 4 squared is 16 on 2 is 8, and then I've got a plus here, so that will be 4 by 2 is 8, so it'll be take 8 here. And then if I work all that out, which equals 73 on 2. Okay, alright, next one. So here I'm going to have to use my anti-chain rule to integrate. That's okay, I know how to do that. So the integral from 1 to 5 of 2x plus 5 squared, first thing I do is I integrate. So it's going to be, and I'm going to have to go over 2 lines, so it's going to be 1 over 2, so if we divide by the derivative of the inside, it's going to be 2x plus 5, add 1 to the power to give us a 3, and then divide by 3, and we're going from 1 to 5. Okay, alright, so that's going to be a 1 on 6, so brackets, 1 on 6, 2 by 5 plus 5 cubed, take 1 on 6, 2 times 1 plus 5, all cubed. So again, our brackets are really important here. So here we're going to get 15 cubed on 6, take, and here it's going to be 7 cubed on 6, and if we work that out, so this equals 1516 on 3. Okay, and I'm just calculating those on a calculator. Again, we need to use an anti-chain rule, so it's going to be integral from 0 to 4 of e to the power of 2x plus 3. Okay, alright, so the integral of an exponential is just the same thing, so it's going to be e to the 2x plus 3. We're going to have to divide by this 2, and it's going from 0 to 4, so it's e to the power of 2 by 0 plus, rather we've got to do right hand first, so it's 2 by 4 plus 3 on 2, take e to the power of 2 by 0 plus 3. Let's say we'll ask for an exact value, so we can't just do this on our calculator. So what's that going to be? That's going to be e to the 11 on 2. Take e to the 3 on 2. So it's e to the power of 11, take e to the power of 3 all over 2. And that's as far as we need to go for an exact value. Okay, and then the final one is with a trig. So here we can just do a straight rule. So it's going to be integral from 0 to pi on 3 cos x plus cos 2x dx. Okay, alright, integral of cos x is sin x, and the integral of cos 2x is a half sine 2x. So we need to divide by the derivative of the inside in this case, and we're going to go to 0 from 0 to pi on 3. Okay, here we're going to need our bracket, so nice big open bracket is going to give us sine pi on 3 plus a half sine 2 pi on 3. Close off that bracket and then put a subtract, and it's going to be sine 0 plus a half sine of 0. 2 times 0 is just 0. Close off that bracket. Okay, alright, sine of pi on 3 is root 3 on 2 plus a half. Now sine of 2 pi on 3 is also root 3 on 2. Take, now sine of 0 is just 0, and sine, so that's just take 0, take 0. So here we get root 3 on 2 plus root 3 on 4. You could work that out as a decimal, but we want an exact answer. The way I look at this is I look at this here as a half root 3's plus a quarter root 3's. So what's a half plus a quarter? Well, it's 3/4. So this is going to be 3/4 root 3, which we better know as just 3 root 3 on 4. So it can be helpful just to see it like that. And that's as far as we'll go today. Okay.